Let's look at the Compactlogix L18ERM controller. This is the same controller as the L16, except this has a little bit more memory in it. The 8 has a little bit more memory. Also, the M on the ERM means that this one can issue motion commands and talk to servos. The L16 ER does not have motion capabilities. So let's talk about these indicator lights up here on the top. We have the run light. Okay, normally we like to see that green. If we don't see run light, it's not in run mode. So you want to look for that. Forces, if you have forces on, you'll see a light turn on there. If you have I/O issues, you'll see this blink. If I/O is okay, you'll see it green. The OK light is also my fault indicator. I like to see a green light on OK. If I see a red light, it's faulted and has shut down. So that's not good. Network status is this indicator, NS. I like to see that just green as well. Link 1, link 2. I have 2 Ethernet ports on the front. Port number 1 is on the top, or the front they call it. Port number 2 is on the bottom. Okay, port number 2 in this case is a pass-through port, so I can plug other devices into this port, and it'll communicate with those devices. Okay. SD is the SD card. There is an SD card behind the trap door here. Okay, the SD card can you can save an image of the processor to the SD card, so it will boot from the SD card if you would like to do that. That's in case your processor memory gets wiped out. You should still have a copy of the program on your SD card. Okay, right here the switch, it's very important. Program mode on the bottom. When you're in program mode, you cannot put it in run mode through the software. So you'll put it in program mode if you're going to do a firmware update. You'll have to do it in program mode only. Or if you don't want someone else to put the processor in run while you're working on it. So you can physically put it in program mode and you don't have to worry about it. If you put it in remote mode, REM, you can stop the processor, you can program it, you can run it through the software across the network. So that's handy if it's physically remote and you don't want to have to go and flip the switches on it. You can leave it in remote. I wouldn't though. Once I have it programmed and it's running, I'd like to leave it in run mode. That way, somebody can't accidentally log onto the processor and do some damage to the program, accidentally or on purpose. It's hard to say anymore. You don't want people getting in there and changing things without you knowing it. So putting it in run mode is a good, simple way to make sure that doesn't happen. So just keep that in mind. Also, while we're on that topic, I have seen processors fail to start up automatically when power fails and comes back on if it's in remote mode. Okay, and it's kind of rare, but I have seen it happen. So if you're finished programming it, put it in run mode, so every time the power fails, it'll come back up okay. Okay, so just keep that in mind. Close that and leave it alone. Okay, so over here, the blue, it's hard to see it. Blue is input. So I've got 16 input connections, 0 through 15. Down here at the bottom, on these 4 connection points, they're labeled V. V is voltage. So this header has 24 volts coming out. It goes out through a switch and goes back into the other port. Okay, so let's say number 7, for example. You come out of V with a wire, go out to a switch, come back off the switch into pin number 7. Okay. The green, that's the output connection. Output. These outputs put out 24 volts. So down here at the bottom, I have C connections for common. That's the negative, the return. So let's say I turn on output number 15. I hook a light from 15 to the light, from the light back to common, and the light turns on. Okay, if I forget to bring back that common connection, nothing happens. Um, so these are positive outputs. They put out voltage. The loads connect back to this common, to C. Okay, these terminal blocks are removable. So make sure that if something's not working right, make sure they're snapped in correctly, because sometimes people take them out. Also, if you'll notice, I have a wire. I just plugged the wire in there to bring voltage in the input 0. In order to get that out, I have to push down on that little pin. I've only got one hand, so I'm gonna give it a try here. Push down on that pin and pull. Okay. So the wire will slide right out. There's no screws on it. You don't need a screwdriver to make this work. I'm gonna plug this in somewhere else. I'm gonna plug it in here on 1. So if you'll notice, all I'm gonna do is push that in, and it's done. Got the spring-loaded contact in there. It's great. Normally the screws strip out, like these power screws are already getting a little wear and tear on them there. And these screws would be even smaller, so I don't like screws on these tiny terminal blocks. Okay. So I've got input 1 hot wired back to 24 volts. If I turn this on, I should see input 1 turn on. So let me reach around. I'm going to plug in. I've got a power supply. Got 24 volts on it. Power supply that I bought, it can put out about almost 4 amps. It's important to not get a low power supply, because when this thing starts up, it's gonna need a good 2 amps or so to get fired up. Let's look at the indicator lights. What'll happen is, if you don't have enough power, it will stay in this OK mode forever, and it will never actually boot up. So let's watch it and see what it does. It takes a little bit of time for it to wake up. Okay. I always wonder if it's working. It takes a good while for it to boot up. So you see it's going through some diagnostics. I should see input 1 light up. There it is. Okay, I'm in run mode. Why is that? Well, because I left it in run mode right here. Let's go back to program mode. Run went out. If I go to remote mode, halfway up, nothing. Go to run mode, I go back to run. Network status is blinking. That's not a problem. I just don't have anything connected to it. I/O is okay. OK is okay. That's always good. It's not being forced on. I don't have any outputs forced on. You can see that. I don't have a Ethernet plugged in to link 1 or 2. If I did, I'd see some blinking lights there. What else can I say about this? Oh, last thing. If you ever fault the processor, let's say you get a red OK light and it faults and shuts it down, you can just walk up to it, put it in program mode, go back to run mode, and it will clear that fault for you. But if the fault is a recurring fault, it's going to fault again. So there are 2 ways around that. I don't want to go off the deep end here, but you can write a fault handling routine that will automatically clear the fault for you, or you can just find out what's wrong with your program and fix it. And that's really the way to go. There are a lot of instructions in the programming language that if something goes wrong, it'll fault and shut down the processor. So we really don't want that. You can change some of the settings to where it may not. You can almost tell it to not fault on certain things. So that's a lot of details. I guess later on we get into that. But a fault is really a very bad thing. I've seen systems where one little thing, like The most minor thing you can imagine causes a processor fault, and it shuts down the whole system. The problem with that is if it just turns off and loses control, everything that was going, it could continue to run. So it's a dangerous situation. We don't like processor faults. We either want to have a fault handler where we just shut things down in an orderly way, or we want to just make sure our program doesn't fault. Okay, and that's really the way to go. So, so I've got that input plugged in there. I guess I could pull that out and make that light go off. Let's give that a try with one hand here and try to push that in. Okay, let's plug it in somewhere else. You can see it as I plug the wire in different places down here. I get different inputs turning on. So I'm just checking the inputs, make sure they're okay. Looks good to me. I'm gonna leave it there. One thing to be careful of, there is a fuse, an internal fuse that feeds the FP, that feeds the actual I/O itself. So if you short out your outputs, if you short them to ground, you'll blow out that fuse at some point. It is sort of replaceable. You have to tear it all apart. It's buried inside the processor, but you can do it if you ever lose power to the field connections. It's repairable, but you have to tear it all apart to do so. So that's my short intro to the Compactlogix processor. The next step would be for us to go ahead and hook it up. This one you can see I've got an IP address in it already. There's two ways you can do that. One is you can go on the USB here and set up the Ethernet port. Or Allen Bradley has a tool. It's a software tool that lets you look for MAC addresses. And there's your MAC address. So what you do is you plug an Ethernet into this, and you put it on your local area network, or you just plug it straight into your laptop, and then you just turn on that tool, that software tool, and it will find an unassigned MAC address. Once you see that, you tell it what you want it to be known as, which in this case was this IP, and it configures it for you. And then when you go back through the RS Links tool, you can see this IP address pop up. So that's enough about that. The next stop will be maybe some software demo